In this tutorial, I want to talk to you about sprites. Sprites are absolutely fundamental to Gideros because they're the only things that can be drawn on screen. There are various different types of sprites supported. Let's have a look at the Gideros documentation. If you find the documentation, and we go to the reference manual, you can see that there are various different facilities within Gideros, all arranged within classes. But not every class is a sprite. The bitmap class inherits from Sprite, so that means every bitmap has all the facilities that a sprite has. In this tutorial, I want to deal with both bitmaps and another type of sprite called shape. As you can see, shape also inherits from Sprite. So a shape will have all the features and all the APIs that Sprite does. Sprite has a lot of APIs that you can use, a lot of methods that you can run. So every bitmap and every shape can be, for example, added to as a child to another sprite. You can discover its height, and you can do things like setting its scale, which you'll be doing today, setting its position, setting its rotation, and so on. If you look at the documentation for bitmap itself, it doesn't reproduce all of those facilities. So you don't see bitmap set position. That's what it inherits from Sprite. That's one of the methods it inherits from Sprite. All you will see in bitmap is the additional features it has. Today I'm going to use bitmaps and shapes to create a face. I'm going to create a very interesting face which we can rotate on screen. And we'll understand how you can put sprites together in groups to move them around as one entity and create more complex shapes. Okay. Let me start by opening Gideros Studio. And I'm going to create a new project. Let me browse for the location where I want to put this project. I'm going to put it in the Gideros examples. I'm going to call my new project Face. And I've told it to create a directory for the project, which means it will create a directory called dgideros examples face, and within that it will create a file called face.gproj, which is the Gideros project file. Okay, let's see what it created. Within Gideros examples, there is a folder called face containing the Gideros project file, but there are no other files present because I haven't written any code yet. I want to start off by adding some assets. I already have two assets loaded, i.ping and nose.jpg. I'm going to drag these into my project folder. Let's get started with programming. I'm going to add a new file. I will call my file main.lua. That's the usual name for the main program of a Lua program. Typically, with a larger project, you might have several program source code files, but I'll only have one called main.lua. Okay, I'm going to create my first I, and it's going to be a bitmap. I1 equals bitmap.new. Bitmap.new takes a texture. How do I create my texture? I use texture.new, and I get to quote the name of my bitmap texture that I want. In this case, I want to use i.ping. i.ping. Let's start up Gideros Player, and I'm going to make sure that it has always on top, which makes it easier for me to rapidly switch between these two programs. Let's press play. Immediately I encounter a problem. It can't find i.ping. It says there's no such file or directory. Why is that? After all, i.ping is present in the correct directory. What we need to do is we need to add i.ping to our project called face. Files must be explicitly added to your Gideros project. So let's add i.ping. And while we're at it, Let's add nose.jpg, which we're going to need as well. Let's try running that program. Okay, it worked correctly, but nothing appeared on the screen. The reason is we forgot to add I1 to the stage. The stage is a sprite as well, but it's a special kind of sprite. Everything must be added to the stage to be visible on the screen. You can add things either directly to the stage, as we're doing now, or indirectly, which we'll cover later on in this tutorial. But now we've added the I1 to the stage, it should appear on the stage. Let's run that. There's the eye, but boy, it's way too big, right? I want this eye to be much smaller. Let's scale it. I1 set scale 0.25. Now it'll be only a quarter of the size it was before. If I only have one argument for set scale, then it scales that amount in both directions. So it will scale a quarter in both the x and in the y direction. If I want to scale differently in the two directions, I can have two arguments. Let's add another eye in exactly the same way. I2 equals bitmap.new i.ping. I've used the same texture, which of course is okay. Let's also add this I2 to the stage. Well, again, my new eye is far too large. Let's rescale it. No. Let's make sure we scale I2 rather than I1. And let's position it somewhere so it's not directly on top of I1. I use the API set position. Let's put it at 140 pixels along. Well, now I've got two eyes, but really this eye on my left should be rotated. Because it's both eyes are of the same sort. In fact, instead of rotating them, I really want to scale it. I want to scale this second eye. I'm going to move I1 across to 140, and the I2, which is the one to my left on the screen, I'm going to scale it. Well, I've already scaled I2, but I actually want to scale it differently in different directions. I want to scale it with a negative amount in the x direction so that it flips over in the x direction. Well, it has flipped over, but it's actually flipped about the axis which is on the far left of the screen, so it's flipped right off the screen. By default, the anchor points for all sprites are their top left-hand corner. I won't change that default in this tutorial, but you can change it using the set anchor point method. To bring the I2 back on the screen, I'm going to use another set position command. I'm going to put it at 80 and 0 for the y coordinate. Now I've got two eyes on screen, and the one at my left, which is the person's right eye, I've rotated. I'll call it the left eye from now on, because it's from my point of view. Now I've got two eyes, and I've rotated them, so it starts to look a bit like a face. Let's add the nose. The nose will be based on nose.jpg. Nose equals bitmap.new texture.new nose.jpg. Let's add it to the stage straight away. Stage, add child, nose. Okay, well, the nose is obviously way too large, as before. Let me scale it down. This time I'll scale it to 50%, and in both directions, because I don't need to flip this over. Okay, well it's covering the first eye. Let's move it to somewhere more appropriate. Nose, set position, and I'm going to use the position 80, 60. Yeah, that's a good fit. So now it starts to look a bit like a face. For the mouth, I don't have a bitmap. I'm going to try drawing a shape to make the mouth. Let me show you how to do that. Mouth equals shape.new. And you notice this factory function shape.new takes no parameters. Now I need to draw the various coordinates of the shape, which is a filled polygon. So a shape is just a filled polygon. I need to draw the various vertices and also specify the type of fill I want and the line style for the outer rim of the polygon. So I'm going to say mouth, begin path. This creates a continuous path which will be made out of line segments and will loop back and join itself at the beginning. I'm going to move to the coordinate 0, 0. So I'm moving my virtual pen to this coordinate. This doesn't cause anything to be drawn yet. I'm now going to draw a line 2, and I'm going to choose 200, 0. This causes a line to be drawn from my first coordinate 0, 0 to the coordinate 200, 0. I'm going to again do a line 2, 100, 50. And now I'm going to close up my polygon, which is actually just a triangle. Line 2 with a little l back to the start. Let me change these. And when I finish drawing a path like this, I should end path. That should complete the specification of my mouth. Let me add the mouth to the stage. So stage, add child mouth. Zoom out. Well, nothing has appeared, although there's no error down here. The reason nothing appeared is because I forgot to set the fill style and optionally the line style. Let's do that now. Mouth, set fill style. This takes two arguments. The first argument specifies whether I want to fill my polygon shape with either a texture or a solid color. I'm going to choose a solid color. This parameter shape.solid is just a symbolic constant. Now I need to specify the color in the second argument. In Gideros, colors are specified using a single hexadecimal number. I'm going to choose red. So what this means is FF means full amount of red, which is a number between 0 and 255. And then we've got 0, 0. That means no amount of green. And 0, 0 means no amount of blue. Let's see if that draws something. It does. So now we have a triangle like I wanted. But of course it's in the wrong place. Let me set the position of this mouth. Mouth, set position 10, 160. There you go, it kind of looks like a face. Let's just experiment with changing the colors a bit. If I were to make it 0, all zeros, then it would be a black mouth, right? Red, green and blue channels are all fully 0. Let's make it blue. And actually I could, if I just wanted it blue, I could simply say 0xFF. Or simply 255, which is the decimal version of the same thing. If you want to add all the channels, it's easier to use this hexadecimal version. Let's go back to FF0000. I can actually use capital Fs if I want as well. There's my red mouth. So far my shape consists of a shape.new, and then I've got a begin path all the way down to an end path. Now there is a convenience function called close path. So instead of doing this final line 2, I can do close path, and it just joins it up. It joins the shape up back to where it started, namely at 0, 0. So that's exactly the same. Let's add an outer rim to this shape. So we're going to add a line going around the shape. And this is done using setLineStyle. The first parameter is the thickness, and the second parameter is the color. I just want this to be black, so I could either enter it as, which is probably more helpful, but I could just enter 0. It wouldn't make any difference at all. There you see the shape now has a perimeter around it. A black perimeter of 2 pixels thick. Now it's worth noting that I don't need to have just a single path in each shape. A shape can consist of multiple paths, which might be connected to each other or entirely separate. So let me add another path. If I just copy everything, for this second path I'm not going to bother with a line style, but I will choose a fill style. I'm just going to make it black, so I'm just going to enter 0 for now. I'm going to start by moving to 40, 10. And then I'm going to go to 160, 10 and 100, 40. And I'm going to close the path. This is a smaller triangle that should be inset within the bigger triangle. Let's see if that worked. Yes. So that's the face I want to draw. And it's worth noting, where is this shape actually positioned? I've positioned something at 10 by 160, 10 pixels along and 160 down. But what I've actually positioned is whatever this 0, 0 is. So when I start, I create the first corner of the mouth, which is the left-hand side of the mouth, at 0, 0. And when I position the shape at that, at a certain point, then that coordinate, the one that's been set to 0, 0, is at the coordinate I specified. So the left corner of the mouth is at 10 by 160. The right corner is displaced by 200 pixels, so it will be at 210 by 160. So in this way you can effectively set the anchor point of shapes just by drawing them in a certain way. Okay, lastly, I want to add a face to go around the whole thing and give an overall shape. Creating a face is also going to be a matter of creating a shape. So let me copy this shape. And I can do Control H to replace. If I replace mouth with face, oops. Let's minimize that. And I'm going to replace. There you go. So I've created a new shape called face. Going to have a line style of 5. In terms of the color, I think I'll choose a gray color, so I'm going to have 80, 80, 80. That's in hexadecimal, so that's roughly halfway between black and white for all 3 channels, so it'll give me a gray color. I'm going to set these coordinates to starts at 0, 0, goes to 220, 0, goes to 220, 220. I'm going to need another coordinate because I want to create a rectangle now, not a triangle. And that's going to be 0, 220. Finally, I close the path and end the path. I must remember to add the face to the stage. Let's see what that did. Oops. Well, the problem here is that my face has been drawn on top of all the face parts, the mouth, eyes, and nose. To overcome that, I can use this add child at method. And if I'd say add child at face comma 1, it's going to add the face as the very first child of the stage, meaning that the other children will be at higher index numbers and will be drawn on top of it. Well, that's a pretty creepy looking face, right? Now, what if I wanted to move the face around? If I were to say, I've already positioned the face, I haven't positioned the face yet. If I were to say face set x 20, currently the position of the face is 0, 0 because I never set the coordinate of face, so that means its default coordinate is at 0, 0. Well, that didn't really do what I wanted. It did move the face part, but it didn't move the eyes, it didn't move the nose, it didn't move the mouth, and it'd be rather tedious to move all of those manually and go through all those bits and move them. I could do that. What would be better would be if I were to define the face and then add the other parts on top of the face as children of the face. And I can do that. Let's start by adding the face right at the beginning. So if I go to the beginning of the file, I create the face to start with, so now I create the face. And I might as well add it on the stage as well. I'm just going to use the regular add child API for now. So I create a face and I add it onto the stage. Now instead of adding the children to the stage directly, I'm going to add them onto the face. So I say face add child I, face add child I2. I can continue to set the coordinates of those children, but these are going to be local coordinates, local to the face, so wherever the face moves, the eye position will be relative to that. Let's create the nose, but let's add it to the face as well. Let's create the mouth in all its various parts, and let's add that to the face. Let's see what that does. Well, the face looks exactly the same, but there's an important difference. Now if I do face set x 20 and run that, you can see the entire face moves over. The reason is because the eyes, nose and mouth are all children of the face. So when you look at the coordinate, for example, of eye number 1, I set its position at 140, 0, that's relative to the face. And now I've set the face to be x equals 20, so the coordinate of the eye is now actually 20 plus 140, which is 160 pixels. That actually relates to the right-hand eye. If you look at the left-hand eye, its position is 80, so when I set the x of the face to 20, the coordinate of the eye is 100. So in this way I can move the face anywhere I want. So if I set position 50-50, the face goes to 50-50. Okay, let's put it near the center of the screen like this. To finish off, I want to do some animation. Let's have a function which will rotate the entire face. I call this function update face set rotation. This is another method that you can use on all sprites to set the rotation of the sprite. And when I rotate the entire face, all the parts on it will still be within the face and they'll rotate with it. Okay, so that means I'm going to set the face's rotation to be the face's current rotation, which I get using the getRotation command, plus 1 degree clockwise. So the face will now move 1 degree every 60th of a second, every time this update function is called. I could have done that in 2 steps as well. Let me practice doing it in 2 steps. I create a local variable called angle, which will hold the current rotation, and I set the new rotation of the face to be angle plus 1. Or even get set angle, right angle equals angle plus 1, and set the rotation to be the new angle. I use the local variable here because it's always a good idea to make sure that variables within functions are local to that function and won't interfere with the main program. In order for this function to come to life, I need to use the addEventListener method. So what I'm saying here is every 60th of a second an event listener will be fired, and that event listener will call the function update. Right. This should now cause the face to rotate, and it does. Let's have a bit more fun. I want this nose to be at a slight angle, as if he's a little bit beaten up. And notice this is again the local angle. Let me comment that out for a minute. You can see the nose is slightly rotated. But this setting of 10 degrees, when I set the nose to have a rotation of 10 degrees, that's not the absolute rotation. As the whole face rotates, it will be more than 10 degrees. It will be the face's rotation plus 10 degrees will give me the total rotation of the nose. So that this is always a local angle. And whenever you set rotations, positions or scales in Gideros, it's always local to the sprite. It's not the total or global rotation, position or scale. That will be decided by considering the parents of the sprite. So if you rotate the whole sprite, then you don't need to change the rotation of any of the things within it. They will be automatically added on, so the whole thing rotates. So I can now uncomment this, and now I've registered my update function, and there we go. I want to finish off just by returning to the documentation, just to get a bit of an overview of all the different sprite types there are. You can go through this yourself, and you should get used to looking through this API documentation. We've already seen Bitmap inherits from Sprite. Let's see what else inherits from Sprite. Another one is Mesh. Mesh allows you to draw a large number of triangles in one go. You could draw triangles using the shape command, as we've already seen. We've already, in fact, drawn a triangle. But the Mesh command allows you to draw hundreds or even thousands of these triangles very rapidly, and what you do is you set the coordinates of all those triangles and then give it all over to Gideros, which draws them all in one go. And this can be a very powerful tool. So Mesh is a large array of triangles. As you can see, it again inherits from Sprite. So once you've created a mesh, you can bodily rotate, translate, or scale the entire mesh. Mesh is also the gateway to 3D objects in Gideros. Gideros allows 3D sprites to be drawn, and to do that, when you create your new mesh, you need to pass it the parameter is3D. If you pass that true, then it will create a 3D mesh. If you leave out the parameter or set it to false, then it creates a default 2D mesh. So we got meshes. Another one is MovieClip. Again, inherits from Sprite. The MovieClip allows you to create animated sprites. It's not necessarily associated with visual movies or TV shows or any sort of media application like that. It's not about playing an MPEG or a video file. It's more about creating an animated sprite where the appearance of that sprite changes with time over a series of frames. So it's quite a powerful technique. That's MovieClip. Path2D is another type of sprite. This allows you to draw sprites which are made out of arbitrary line segments, including complex curves and so on. So as you've seen in this example, we were able to draw a simple shape, but you notice that shapes are made entirely out of lines. You have these move to and line to commands, so they're just made out of straight lines. By contrast, the Path2D system allows you to draw shapes made out of arbitrary curves and other shapes, and basically it creates an SVG style shape made out of vector graphics. So Path2D is a fairly recent addition, and it's a very powerful way of drawing complex shapes. Shape we've already seen. It's worth noting that you can instantiate a raw sprite all by itself. A sprite is invisible, so you might think, why would I create a sprite? The reason is that it acts as a holding area for other sprites, a sort of invisible group that you can put things into. In our case, we first of all instantiated a shape, and then we added children to that shape. So we created a shape called face, and then when it came to I1, we positioned I1, but we also added it to the face. Face add child I1, face add child I2. We could have created face as an empty sprite using sprite.new, and then added the face shape as another child. So just creating a raw sprite is often useful when you want to create just invisible areas which are simply there to group sprites within them. So sprite by itself is kind of a grouping object. And of course it has all the usual sprite features. Stage, we're familiar with stage. There is only one stage, but it inherits from sprite, and it's just a regular sprite, so you can move it around and so on. Typically you wouldn't move the stage around, rather you add sprites onto the stage and move them around. You can see the stage has one additional method in addition to all the regular sprite methods, which is set clear color buffer. And this is just either true or false, and it dictates, it's a logical variable, it dictates whether to clear the background or not, because if you have your entire background covered in a bitmap, there's no need for OpenGL or DirectX to clear the entire screen to a solid color. TextField allows you to draw text. It again inherits from Sprite, and to draw text you need a font. So you create a font, you then create a text field based on a font and some text, and since TextField is a regular sprite, it can be added to the stage, you can position it, rotate it, and so on. TileMap is a final example, one more sprite type, and it allows you to create repeating tiles. Probably if I show you this, it's easier to understand. One of the examples in Gideros is a TileMap example. Actually, there are two of them. One is called the desert. And you can see my only graphic here is this rather simple set of shapes that have been put together into what could be called a texture atlas. When I play this example, you can see a very complex maze has been built up by repeating these little subshapes. And that's what a tile map allows you to do. So for example, you take this shape and it becomes the top of this wall. And by repeating all these little shapes within the tile map, you can create a complex map in a very efficient way, which is very memory efficient and very CPU efficient. And it also means you don't have to do huge amounts of artwork. You don't have to design this entire maze as a single bitmap, which would be a complex piece of artwork to do. Rather, you can repeat all these little subsections very easily. And actually, Gideros interfaces with a level editor called Tiled, which is another open source and free program you can download. So you can create your levels offline, export them, and import them into Gideros. So both Tiled and Gideros work together to create complex levels. The final sprite is Viewport. This is a very recent addition which allows you to view the entire scene from different angles and positions. Basically, it allows you to create a split-screen game where, for example, two players are playing each other and the top of the screen shows the point of view from one player's point of view, the bottom of the screen shows the scene from another player's point of view.